Hello, everyone, and welcome to today's online Rancher Meetup. We have an excellent session scheduled for you today. We are going to be doing a deep dive on Kubernetes networking and really going through a lot of the concepts around how teams are using Kubernetes to connect different types of application components. So we've got a couple of awesome speakers joining us today, but just as way of introduction, I'm Shannon Williams. I'm one of the founders here at Rancher and run our marketing and sales teams. I am typically joined by Darren, my co-founder, but Darren is on vacation this week. So in his place, we have two fantastic engineers who will be diving into the depths of Kubernetes networking. Murali is based in Phoenix, and he is our lead engineer on all things networking. He'll be walking through and explaining container networking, Kubernetes networking in detail, and taking your questions on those topics. And Alena is based in our California office in Cupertino. She has led all of the work on Ingress and load balancing here at Rancher for the last 3 years, and so she'll be talking about what we're doing on that side. So we should have an excellent session, and thank you all for joining. We have, as always, hundreds and hundreds of you on the call. So thanks for attending. And I think one of the reasons this meetup has always been so popular is that we really do try to treat it like a meetup and not a marketing webinar or something where we're kind of going through a bunch of slides and showing you things. So what that means is we will not be done on time. We don't set a time end for this. So if you're concerned at all about that, just know we record the entire session. All of the content is recorded. It will be on YouTube within a couple of days. And part of the reason we don't set a time is because we get literally thousands of questions during these meetups from people, and your questions are welcome. We try to answer them using the questions app that you'll see on the GoToMeeting console. So if you have any questions, please put them in there. I may repeat your question out to Murali or Alena if it's something that is kind of connected to what they're asking right now. If your question is more something that maybe is just a general Rancher question, you're struggling with storage, or you're trying to figure out how to use EKS or GKE, I'll try to answer them or Denise, who's one of our other engineers, will try to answer them. So we'll be out kind of engaging with you on the question side, but be patient. Sometimes it takes us 30 minutes to get back to someone's question because it's a topic we know we're going to be covering in a little bit. The other big thing is we are going to demo quite a bit. So both Murali and Alena will be demoing. This is probably one meetup where we will have more slides than usual. Usually we try to keep the slides to a real minimum. But in this case, we are kind of diving into a lot of deep networking concepts, and we are going to use slides to walk through and explain things. All of the slides will go up on SlideShare. All of the content will be available as a recording, so don't worry about taking detailed notes. But we will try to be jumping back and forth between kind of running clusters, showing you how some of this stuff is implemented in Rancher 2. And as always, because it's a demo, things sometimes don't work correctly. We get hung up, networks fail. Please be patient. We'll try to we try to have backups in place, but if something's not working quite right, we may jump over something or another. With that, I just want to thank you all for becoming such a part of this community. We run these meetups every month. Most of the time, we try to connect to one another on Twitter. So we use the hashtag on Twitter, Rancher Meetup. We try to stick it on many of the pages, so you kind of have that as a reminder. If you have something you would like to share, but you want to kind of share it on that format, please do. I will, when you're asking questions using the questions app, though, unless your question is very, clearly marked sort of private, please respond only to me. I'll often respond to your question to the whole group, so everyone can see the question that was asked and the answer that was given. And in fact, if you see a question that maybe, I respond with I'm not really sure about this, feel free to send the answer in as a question, and I'll respond and send that out as well. So the question channel kind of works like a Slack channel while we're here on the meetup. But if you're first time here, please post a picture on Twitter and introduce yourself. Tell us who you are. Hashtag it with Rancher Meetup. We'll add you to the hundreds of pictures that are buried here on my screen. And we're really excited to have so many people interested in these topics. So our agenda today, first I'll just do a really quick introduction of who is Rancher and for new people to the team. We will then, Murali is going to go through and just do kind of a high level on Docker networking and Kubernetes networking will be the main focus. So we'll kind of just touch on some high level concepts around virtual networking and overlay networks before diving into, kind of what's really going on under the covers at the networking level within Kubernetes. We'll talk about Kubernetes networking plugins, including Flannel, Calico, Canal, and kind of explain when you might choose different networks for creating a Kubernetes cluster. Then we'll demo quite a bit of Flannel. We'll probably also be covering things like service mesh, or not service mesh, but service discovery and DNS and other pieces as we go through and try to demo those concepts. Once Murali's done, and his session will probably take a good 40 minutes, I think, given the amount of questions I anticipate and the amount of content there. Alena is going to come in and talk about Ingress controllers and load balancing and demo, sort of how to use load balancers and Ingress in Rancher 2.0. Finally, whatever questions you have left, if they haven't been answered, we will not leave. We'll stick around. We'll answer them to the best of our ability, and we'll try to get all the answers done. We have been trying to capture the questions and also post those to GitHub or somewhere. So if you have a question and you want to go back and see what the answer was, we're trying to publish those out as well to make all this stuff public. With that, I did want to just sort of ask a quick poll question. Often we have these huge groups, and one of the questions we're not always clear on is how much people already know about and are using Rancher. So I just threw up a question to you now, and just asking kind of, how much you're using, or how much experience you have with Rancher. It's really, I'm either getting started, we've using it a ton. I'm an expert. I've been using it for 3 years since Rancher first came out as a beta back in 2015, or you're just kind of getting educated and learning about it. So I'm going to leave the question open for 3 more seconds. And 3, 2, 1, and we're going to close it. And it looks like, let's see, I think I closed it. It's still in progress. Oops, that's not what I wanted to do.
I see a close poll button. Do you want me to close it?
If you can, yeah, I can't get it to close when I click on the close poll button. There you go, you did it. I don't know why you can. Can you click on the share button too? Oh, there we go. Now it's shared. So it looks like we have about 40% of people are just learning, and about 55, 57 people have either deployed it but trying to figure it out, or using it more heavily in their team. So great. We've got a lot of people who already know Rancher, but also a lot of people where it's new to. Just for those of you who aren't familiar with Rancher, Rancher is an open source project that is used to manage all of your container environments using Kubernetes in an organization. And so, in most teams, they'll start by deploying Rancher and use it to create either one or more Kubernetes clusters, run it either specifically in one cloud or on premise, or deploy it to even an existing Kubernetes service like GKE or EKS. And what makes it really useful is it kind of sits at a level above Kubernetes. So if you think of kind of Docker at the lowest level, sitting on the host, and Kubernetes at the center of the cluster management, Rancher is like a full container management platform that's also open source, just like Docker and Kubernetes. So there are tens, kind of 10,000 plus users of Rancher out there today, including companies of all different sizes and shapes. But for most of those organizations, they're using it because Kubernetes is becoming more and more of a critical part of their ecosystem, and they either are using Rancher to build out Kubernetes clusters on bare metal or vSphere, or they're importing clusters from places like Google and Azure and EKS, where you can get clusters on demand, or existing clusters that they have spun up using KubeSpray or anything else you can use to create a cluster. And what Rancher does is all of the sort of unified management across those clusters. So it integrates to your Active Directories, it sets up auth, it manages sort of how you can, who can access which clusters and what they're allowed to do, and sort of sets like the kind of IT level policies about these clusters, but then also provides a fully integrated sort of workload management layer where teams can, get access to the cluster they have access to, and then deploy applications from a catalog, get a UI for Kubernetes, use Prometheus monitoring and logging integration and CI/CD and everything else around the cluster to be more productive. So it's really like a full platform for taking Kubernetes and pushing it into your organization as more of a service that anyone can access and consume. So very much around multi-cluster management. So that's kind of Rancher. It's fully open source. You can download it. I'll post a link at the end to how to get there. But today's topic is less about Rancher and really more about diving into Kubernetes networking in depth. And to get us started, Murali is gonna share, really the basics of container networking before diving into, kind of the details of what's going on within a Kubernetes cluster at the networking level. So with that, Murali, if you're all set, I'm gonna make you the presenter.
Sure.
All right. You should have the ability to share your screen now. Did you become a presenter?
Doesn't look like it.
Okay, give me one more second. Let me try it over here.
Yes.
Now you are?
Looks like yes. I am a presenter.
No,
okay, can you see my screen?
I cannot. No, I don't think it's making you the presenter for some reason. Not sure what's going on. It's some kind of bug. I keep clicking on.
I'm sorry, Shannon. I actually could see Murali's screen, so I think I actually made him the presenter. So I think there might be something wrong with your end on your GoTo.
Okay, great. Well, then if everyone can see his screen, then off you go, Murali.
Great. And lastly, how goes the activities and outreach? I was looking at it, I was pretty pleased to see. And David has been pretty.
Murali, are you presenting your screen now?
Yes. Can you hear me? Hello.
I can hear you now.
Okay, cool. Good morning, everyone. My name is Murali, and this is the agenda for my talk. So I'll be talking briefly about the container networking, how the various network plugins take advantage of the Linux constructs and how Docker uses them. And then I move over to the various different concepts of Kubernetes networking. And finally, I take a tour over the various networking plugins that are available out there, and what are the different scenarios, how to pick one over the other depends on on the needs. So if you look at the Linux virtual networking constructs, there's concepts of virtual switch or bridge. This is exploited by the Docker to create the Docker bridge, where all the containers are connected to the bridge. They can communicate with each other. And on the picture on the right hand side, you can see on a bare metal server, we could run a container natively, and it connects to a bridge. It could the container could run inside a virtual machine, which is running inside a physical machine. So all of these things are made possible by the various features available in the Linux kernel. And a namespace is also a Linux construct. What it does is basically, it creates a totally different copy of the networking stack with its own routes, firewall rules. So think of it like, like a machine inside a machine kind of a thing. So you get your own networking space and all the networking stuff. So what is Docker networking? Docker basically creates a virtual bridge called Docker 0, and all the containers are connected to the Docker bridge using virtual Ethernet interfaces. One end of this vEth is connected to the Docker 0 bridge. The other one is placed inside the container network namespace, and that's how these containers talk to each other. The Docker network is completely isolated. What it means is it's a private networking which is available within the host. For the containers to be able to talk to services or talk to the internet outside of this host, Docker places NAT rules, the source NAT rules, to provide connectivity to the outside world. And in the same way, Docker also uses some destination NAT rules to make the services available to the outside world, the services which are provided by the containers to the outside world. So IPtables is a Linux program which allows to take advantage of the Linux firewall rules or the net filter module. It has 4 different tables and various different chains. What this means is there are various points available in the Linux kernel where we could change the direction of a packet flow. We could change the source IP, we could change the destination IP, or we could change the source or the destination ports. You can drop a packet or forward a packet. You could do all sort of stuff. So the IPtables is a tool used for such kind of functionality. This flowchart kind of gives a high-level overview of how these tables and chains are arranged in the Linux kernel. If I have to go through this, step by step, I start with on the left-hand side as the entry point. As a packet enters a system, it goes through the raw table and the pre-routing chain. After that, it moves through the contract table, and it goes. And the next step is it goes through the mangle table and the pre-routing chain, and then again it's a NAT table pre-routing. And based on the routing decision, if the packet is destined to a container, it takes a path upwards, and it hits the filter tables. And if there are firewall rules, the packet can get dropped. And if it is an IPsec or a VXLAN packet, then it's called a tunnel packet. Then it re-enters the whole chain again. In the same way, on the right half, what happens is if a local process running on the host sends out a packet, it goes through these chains and tables like raw, output, and then contract, and it goes all the way to the forward, and it goes to the filter forward, and it exits the system on the right hand side. So that's the basic IP table rules which are present on any Linux machine. Now, when we install Docker, what it does is it inserts its own chains. It hooks into the existing tables and creates its own rules. Here in this example, on the left top of the screen, we can see the rules that are inserted when a container publishes its port 8080. Here we can see, any packet that arrives on the host IP at port 8080, it gets denatted to the container IP address 172.17.02 and the port 8080. And in the same way, on the right top half, we can see, we have the filter rules where this packet is accepted. And at the bottom, there are various other rules which make the reverse path of the packet work. So in this picture, on the right hand side, I kind of trying to explain how container to container communication happens. So we have this big box, which is a node, and it has its own network interface, Ethernet 0, which has a 10.29.1.101 IP address, MAC address. And inside this node, we have the Docker 0 bridge, and we have 4 different containers with different IP addresses and different MAC addresses. When a container A wants to communicate with container B, on the left hand side here, we can see the packet format. We have the payload for what the message that container A wants to send to the B, and in the IP layer or the layer 3, we see the source IP and the destination IP and the source MAC and the destination MAC. That's the packet sent from container A to container B. It hits the Docker 0 bridge, and it's get forwarded by the software bridge to the container B. Once container B receives this packet, it replies saying, hey, I got your message, and it fills in the IP and the MAC headers and sends the packet back to the container A. All these packets are forwarded by the Docker 0 bridge. Now, what happens when a container wants to send a traffic out to the internet? Inside the container, if you look at the IP routes, so we have a direct connected route, which is 172.17/16 network, and the default gateway is pointing to 172.17.01. So this IP address is the IP address of the Docker 0 bridge. Did somebody have something to say? Okay. So when container A wants to send a packet out to the world, it sends out, for example, in this example here on the right bottom, I have my laptop. If container A wants to send a packet, it fills in its source IP and the destination IP of the laptop, and it uses a source MAC of the container, and the destination MAC of the container is pointing to the Docker Zero Bridge because that's the default gateway. And the packet is sent out. It hits the Docker Zero Bridge, and at this point, this packet goes through the IP table rules, and here we can see the destination IP, the source IP is natted. The container IP is changed to the host IP, and the packet is sent out to the laptop. That's how the packet egresses out of the host. Now, once the laptop gets the packet, it replies back, and the reply, we can see the destination IP is pointing to the host, and once the packet is inside the host or inside the node, the NAT rules again kick in. They rewrite the destination IP to the container IP address. That's the egress traffic flow. Now, what about ingress? Now, if a container, let's say, for example, here we have this container array. Let's, for a moment, assume this is some kind of a web server, and it has the web application running on port 8080. And we want to publish it to the outside world, and we publish it using the docker run -p flag, and it's published on port 80. Now, when the laptop wants to access this, let's see what happens. Now, the laptop creates a packet and generates the payload. Hey, I want the web page. Here is my source port, and the destination port here is pointed to port 80, which is exposed or published on the node, and the destination IP is the IP address of the node. Once the packet hits this node, the NAT tables kick in again, and what happens here is the IP address, the destination IP address, is translated to the container IP, and the port is also translated. And that's how the packet reaches the container. Now the container does its magic, it sends out a reply to the laptop. The source IP is the container IP, the destination IP is the laptop's, and by the time it is about to exit the system, the NAT rules again kick in, and the source IP is again translated, the source port is again translated. That's how the ingress traffic works. So in this slide, I want to explain what is the difference between Docker networking versus Kubernetes networking. So on the left half here, I have node 1 and node 2. And in node 1, I have a container A, which is a web application, which is using the port 8080. And on the right-hand side, in the node 2, I have a database application or a database server, which is running on port 3000. Now, these two services, when they want to expose their services to the outside world, they use publish ports of the Docker. So here we can see at the bottom half of the screen, we have port 80 being used to publish the web application, and on the right side we have port 9000 being used to expose the database application. So here, any cluster on any setup that needs to publish services, they have to go through this process of managing ports and making sure there is no conflict and things like that. Whereas in Kubernetes networking, what happens is, they have taken a totally different paradigm. Hey, you know what? In the Docker networking world, multiple containers running in different nodes can have the same IP address. Like here we can see on the left hand, container A and container B have the same IP address. Whereas on the right hand side, the Kubernetes guys, they just decided, okay, I'm not going to have duplicate or the same IP addresses. I'm going to have unique IP addresses for all the containers running in my cluster. So, here we can see container A has its own unique IP, 1042.1.2, and container B has its own unique IP address. What this enables us is, we could use the container's IP address directly, and also the port that is actually used by the application. So we don't have to do any kind of a port translation. We don't have to pick some other port, or we don't have to manage these ports. This is all taken care by the Kubernetes engine. So the web app is directly available on port 8080, and the database is available on port 3000. So now we start going over the various Kubernetes networking concepts. The first one is like a pod. I'm not going to get into too many details about what a pod is. For the sake of networking, a pod is at the very least 2 containers, or it could be more containers running together. So it's always a POS container plus a bunch of actual application containers. So here, the main role of the POS container is to bring in the network namespace to the table so that the application containers can use it. So why do the question that I get asked by our customers and a lot of people I meet at meetups and conferences is like, why do they have this concept? The reason is, just imagine if you have 2 or 3 different application containers, they are sharing the same networking stack. If one of the application containers dies, it's going to take down the entire networking stack. So we don't, it causes service disruptions for the other applications running in the same pod. So for this reason, what we do is we have this POS container which brings in the networking stack, and it does nothing. It literally hangs. And then that networking stack is used by the actual application containers. So what's happening is we are decoupling the networking stack from the actual application containers. So if we have to explain this in the Docker world, now what's being done under the hood is we start, let's say, for example, a POS container. Here is the first line that says docker run -- name a POS container. And for example, we choose this Ubuntu image and Sleep Infinity. So here what's happening is we have started this container, which is doing nothing, but it has a network. And in the second line, what we are doing is we are running an actual application, and we are using the networking stack of the POS container. So this is what's done under the hood in a pod. So pod is the basic unit of a deployment in a Kubernetes cluster. Now, as we discussed earlier, every pod in a Kubernetes cluster needs a unique IP address. So what that means is we need a subnet that is used to assign IP addresses to the various pods running in the cluster. So we could choose whatever subnet we want. For example, in Rancher, by default, we use a 1042/16 subnet. And what happens is this bigger subnet is split into multiple smaller chunks, and each chunk is assigned to each individual node. By default, what happens is we do a /24 split. What that means is each node in a cluster gets 256 IP addresses for running pods. What that means is we could have like 256 nodes in a cluster with 256 pods schedulable on each node. Now this is the default strategy. Of course, this could always be changed. Like if let's say if a particular organization doesn't plan to run 256 pods on a single node, it could change these options and customize it to their needs. The important point to note here is the subnet that is chosen for the pods should not overlap with the underlying host network. Even though this pod network is not used for routing outside of the host, but it would interfere with the host routing. So that's why it's very important to make sure the host network and the pod network are not non-overlapping. All right, so we have a concept of cluster IP in Kubernetes. A lot of time people ask, why do we need this? This is again one of the concepts used by Kubernetes to kind of provide resiliency in the cluster. So what happens, if you have a pod and then there is a dependent pod using that particular pod service and that pod dies, then the pod gets recreated on a different node, and it can get a different IP address. Now what happens to the one that is using its services? It has to update its networking stack with the new IP addresses. So that causes a lot of problems. So to avoid this problem, there is this concept of cluster IP. So what it does is it it creates an indirection to actually reach the containers which are providing the actual service. So the cluster IP, it hides the complexity behind, the scaling up and scaling down of the actual pod containers, or if the pods are getting restarted, or if there are failures in that. All of these things are hidden away, and the service which is being service outside to the other components or the other microservices in the cluster, they don't have to worry about it. And there are no network interfaces associated with the cluster IP, unlike the pod seeder IP. The pod IP is assigned to a particular network interface inside the one of the POS containers. But in case of cluster IP, there is no network interface whatsoever. It's totally virtual, and it is implemented using IPtables.
Hey, Murali, I'm just gonna, sorry. So Shannon's actually having a couple of technical difficulties, and we've had a lot of questions coming in, so I'm just gonna jump in and see if you can ask them. They were occurring a little bit earlier in your presentation. It's just, I was trying to work with Shannon on his technical difficulties. Let's see, let me just ask you a couple questions. Is that okay?
Yeah, sure.
So the first one is it mandatory to have IPtables run all the time for Docker networking to work? What happens if you disable IPtables?
So, Docker does provide option to run, without IPtables. It is possible, but there are a lot of other services which are not possible if IPtables are disabled. So the idea is, we need IPtables running for a lot of things.
Okay, great. And then the next one is from, I think, Christoph. It says, Docker networking schema is true only if Swarm is not used. Is that correct? I think that's.
Could you repeat that? Could you repeat that?
Yep. It says Docker networking schema is true only if Swarm not used. I think, I'm reading it word for word, but I think maybe it's just asking if the Docker networking schema works even if you're not using Swarm, maybe.
I see. Okay, so I'll kind of explain a little bit of context for the Swarm. So here in this slide, when I talked about the Docker networking here, so this is the out-of-the-box functionality. There is no Swarm involved. So the moment you bring in Swarm, it creates a new network, it creates a new bridge, it inserts a new networking interfaces inside the containers. So the way Swarm is implemented is unique. It provides cross-host connectivity in its own way. So the picture shown here is the one by default.
Okay. Let's see. And then I have one from Dan. It says, doesn't Docker's overlay networking bypass having to publish ports on nodes?
Does Docker networking allow? Can you repeat that for me?
It says, doesn't Docker's overlay, or I mean, maybe the question, maybe we'll ask it broadly. Does Docker's overlay networking bypass having to publish ports on nodes?
So it does. I mean, at some point, we have to like an overlay network is confined to within the cluster. At some point, if we have to expose these services outside, it has to be published on the host ports, unless we have some kind of custom routing rules which are pointed towards this host, and all these parts are on their own subnet. So it's kind of, you evolve into the Kubernetes network plugin model, or the Flannel's host gateway network plugin model.
Okay, let's see. Sorry, I have a lot that I'm just trying to catch up.
Okay, why don't we try to let Murali get through a few more slides, and we'll come back to some of the questions as we get through. I think there's a lot that are going to be answered as we get into the demo as well.
Okay.
Go ahead, Murali. Why don't you go through a few more of the slides?
Yep, sure. So we just talked about cluster IP. It's an indirection. So to assign these cluster IPs to various services in the cluster, we need a subnet for that. This subnet doesn't have to be as big as the pod subnet. It could be much smaller, and the actual size depends on how many services one is planning to run in this cluster. As it is with the pod seeder or pod subnet, it has to be non-overlapping with the host network. And service discovery. So this is a nice cool feature available in Kubernetes. Now let's say if you have a bunch of services published in in a cluster, how do they reach each other? If they are in the same namespace, you could just use their service name. And if they're in different namespaces, you just have to use service name dot namespace. And if you want to know what is the default domain for the cluster, you could set a default domain, change the default domain from cluster local to whatever you want. And the DNS records are created in this format: service name dot namespace name dot svc dot cluster dot local. And this service is provided by kubedns. It's a component responsible for running like the DNS inside a Kubernetes cluster. By default, there is only one pod which is doing the DNS. Depending on the scale of the deployment, we can scale up and scale down the deployment size of the kubedns. So at this point, let me just switch to demo, and then I could show how the service discovery works. So I have my own installation of a Rancher. Let me just log in here. So I have pre-created 3 different clusters using 3 different network plugins. For this demo, I'll just quickly use Flannel. And in this Flannel, let's just switch to the default project, and let me create a couple of namespaces. Let's say, let's call this namespace alpha. And I will create one more namespace Bravo. And I will switch to the default project, and I will deploy multiple workloads here. Let me create deploy. Let's say this is my workload 1, and it is, let me use an Nginx container, and I am deploying this in namespace alpha. And I launch it. Now let me launch one more workload 2, the same Nginx in namespace alpha. So I have 2 workloads deployed in namespace alpha. And let me deploy a couple of more workloads. Workload 3, Nginx in namespace Bravo. And I will deploy one more workload 4 in namespace Bravo. So at this point, we could So I'm just quickly trying to show how the service discovery works. Curl w1.
Murali, where is this demo cluster running right now? You're running this all in Amazon, or where do you have it deployed?
Yeah, at this point, all of my clusters are using the Amazon EC2 provider here. So I mean, we could create clusters in whatever service provider, like we have all these various options available. So for my demo, I'm using Amazon EC2.
Great, thanks.
I'm just trying to install the curl command. So here we can see the same with the workload 1 is accessible directly by the name W1 from the workload 2 because it's in the same namespace. Now, if I want to use a different workload, let's say W3, which is running in a different one, it doesn't work. But here, if I add the namespace ns Bravo, I can use the service discovery options. So here this summarizes what we have learned. We can resolve the services within the same namespace using their names across namespaces by appending dot namespace. So let's continue with the concepts of Kubernetes. So we have this concept of host port. So this is the exact equivalent of the expose port in the Docker world. The way we do Docker run -p and then specify the ports. We have this construct called host port. This is to expose the services running inside the pod using the host IP address. And for best practices reasons, this is not a recommended thing. So why is it not recommended? Now let's just imagine we have two nodes in a cluster, and on node 1 we have a pod running, and it's using port let's say port 80. And if that node 1 dies, this pod gets rescheduled on node 2. Now, for example, now let's say on this node 2, port 80 was already taken by some other pod. So what happens to this pod? It gets recreated, but on node 2, it's scheduled to recreate on node 2, but it cannot run because the port 80 is already taken. So that's why host port is not recommended. Instead, we have a concept called node port. It's very similar to the expose port, but here what happens is instead of exposing the port on just the node where the pod is running, this port is reserved and exposed on all of the nodes of the cluster. The default port range for exposing services using node port is 30,000 to 32,000. So this is obviously configurable using the flag. So this is the recommended way of exposing the services outside of a cluster. Now let's just see how this is done on the actual cluster. Let me close this window. So here, I have various clusters. So I switch to the Flannel cluster, and I can switch to the default project. Here I could create a new deployment. So let me choose this is using a node port example. I use the Nginx image. I could either add it to the existing namespaces, or I could add it to a new namespace. Let's say I just add it to node port demo namespace. And here, I have this option of port mapping. So I click on this one. So here we can publish the container port. I know the Nginx uses port 80 inside the container to publish the service. It's using the TCP protocol, and we specify a node port here from the drop down, and we can either select but we can enter whatever we want, or we can let the system assign one random port to us. So I'm going to use the random option and go down and launch this pod. Let's wait for it to finish. Cool. So here in the UI, we can see, Kubernetes has chosen a port randomly for us, 31726, and we have this nice little option in the UI where the host IP and the host port, the port is appended. We can just click on it, and we should be able to access the service. Okay, so at this point, this is not accessible because of my security groups. So I haven't enabled, the service port range. So if I just open up my service groups, this should be available. So that's the node port example. And similarly, if you want to use a host port, let's just deploy another one. This is a host port example. And I could choose a new namespace, host port example. I'll use the same Nginx image. Let's add a port. I want to publish port 80, which is running inside the container, TCP as a host port, and I could choose whatever port I want. Let's say I want to choose port 80 here, or port 8080. And so here, we have the the host port example running, and we have port 8080 available here. So as I mentioned earlier, the security groups are not allowing these different ports. So that's how we launch pods with the host ports and the node ports. Okay, so let's move on to the next concept, which is the various networking plugins that are available in Kubernetes. So before I jump on to the network plugins, what is the CNI? So CNI is a standard used by various network vendors. It is shared by everyone in the Kubernetes community. So what this allows is it allows the various vendors to develop custom networking plugins that could just could be used to plug and play, and then they could be used to run various different networking options. So using the CNI plugins, there is a small little inconvenience when you are using a Docker CLI. So what happens is all the networking plugins, when they use the CNI standard, they start the containers with net equal to none, and but they set up the networking out of band of Docker. They bypass the Docker networking stack. So because of this, if you do a Docker inspect, you won't see any networking information, unlike if you were to start a Docker container directly using the Docker CLI. Let me just quickly show it to you, what I mean by that. So let me switch to one of the worker nodes that I have here. So if I search for Docker PS and grep for my workload 1, probably it's a schedule on the other worker node, Docker PS grep W1. So here we can see the two containers. So the first one is the actual Nginx container, and the second one is the POS container. So as we discussed earlier, a pod is always a minimum of 2 containers. So let's inspect both these containers and see what it shows. So here we can see, in the network settings, I don't see any information. And what about the other one for the POS container? So if I do Docker inspect and the other one, even here, we don't see any IP address information. This is the only inconvenience, but the container obviously has an IP address. So we could quickly check that. Docker, let's exec inside this container and do an IP adder. Okay, obviously this is an Nginx container, so it doesn't have the tools to to run and figure out this informations. But if we were to run IP address, we would see the pod IP assigned to this container. So there are various plugins. Most of them, various network plugins, most of them could be classified into 2 different groups. The ones which use overlay option and the other ones which use non-overlay option. So the most popular ones, popular network plugins are like Flannel, Calico, and Canal. So Flannel is a network plugin which supports multiple backends. To provide overlay networking, there are multiple backends available. So we have the VXLAN and the IPsec backends. So VXLAN backend is used in most of the cloud environments where you deploy your hosts in a private VPC, or if you have cross VPC set up using VPNs, so you can just use VXLAN. So this just works out of the box. You don't have to worry about whether the cloud provider has a certain feature or not. So it's just easy to deploy. So VXLAN is the default option generally when we use Flannel in 2.0. So we also have the option of IPsec. When this is used is, let's say you have nodes running in your cluster across the internet, or you're going over the public cloud and you don't have an underlying secure network to secure your container traffic, you would use IPsec. And we have the option of a non-overlay network also. So why would somebody want to use a non-overlay? It's for people who are very concerned about performance. If they do not want to have this extra performance hit because of the VXLAN's encapsulation. So there is an option to use host gateway backend plugin for Flannel. So this provides obviously a better performance, and this is a kind of cloud agnostic. What it means is like you need support from the cloud, but it's not tied to a particular cloud provider. Whereas we have like a AWS VPC backend, this is specifically for AWS. So this is very similar to the host gateway, but it works only inside the AWS cloud provider. And Flannel, by default, it doesn't have any out-of-the-box network policy support. So this is kind of a high-level overview of the Flannel architecture of the VXLAN backend. So we have 3 different nodes, and on the left-hand side, on the first node, we can see we have the Docker 0 bridge, and we have another bridge, and it is assigned an IP address from the subnet that is carved out from the bigger subnet, from the pod seeder or the pod subnet, and the various containers here are using the subnet assigned to this particular node. And when using a VXLAN backend, we see a Flannel interface. So what this does is, when the containers running on node 1 want to talk to containers running on either node 2 or node 3, they send traffic to the default gateway, which is the CBR0 bridge here. And when they need to get out of this box, they go via this Flannel interface where these packets gets encapsulated using the VXLAN headers. So we can see all of these things in the actual setup. I'll get to it in a bit. And in the example of a host gateway backend, what happens is we don't have this Flannel interface, but what happens is the pods which are running on node 1 and the pods which are running on node 2, they can access each other directly by using the pod subnets on these nodes. The routes for this are configured by Flannel, and there is no Flannel interface. But for this to work in cloud providers, for example, in AWS, we have to disable the source destination checks. But if you are using this in a private data center, your underlying network should allow an extra subnet to be traversed to this network. So these are the requirements for this host gateway backend. And Calico, so this is another popular plugin. This is the main backend that is popular is the non-overlay layer 3 option. So here, why this is popular is because there are some enterprises or some people who do not want to use overlay networking, and they want to provide direct routing from their existing workloads to the new container workloads. So Calico provides this option. And the way the container workloads are exposed to the existing workloads is using BGP. So the routes are propagated to the existing network using BGP. This is one of the useful features of Calico, and a lot of people like using this in their private data centers. Generally, this is not used in cloud providers. What I've from the experience that I have had with various customers. Of course, Calico also supports an overlay backend as well. It uses IP in IP encapsulation, and this is the option used in most cloud environments. And obviously, because it's IP in IP encapsulation, the packets as they are going from one node to the other node, they are not encrypted. So one has to make sure the underlying network is either private or secure. This should not be used in public cloud. Let's say if you have nodes from different cloud providers in your Kubernetes cluster, then definitely these are not your options. And Calico supports network policy. And the last couple of slides, here I just wanted to show the Calico's architecture, how it contrasts with Flannel. Here on the first node on the left-hand side, we can see the subnet being used by the containers. We can see the IP addresses being assigned from the pod seeder assigned to this particular node, and there is no bridge here. Calico creates virtual Ethernet interfaces. Here, that is depicted by this line with these two dots. One end of the dot is on the host network directly, and the other one is inside the container. So this is the difference between Flannel and Calico. And based on the backend used, the IP table rules are modified accordingly to provide either IP and IP encapsulation or layer 3 routing. And the IP table rules are also used to provide network policy enforcement. And the last plugin is Canal. So Canal is nothing but Flannel plus just the network policy component from Calico. All right, so let's jump to
Hey, Murali, before you jump on there was a bunch of questions about recommendations and choices of CNI plugins. People asked about WeaveNet, and are there others out there? I mean, these are three that are popular that you're covering, but there are loads of different CNI plugins that are available. First question is, if you were recommending something to someone, you're saying like, hey, this is for 90% of people, unless you have a special use case, this is probably the most tested and straightforward way. What would you recommend?
So if you don't have any special requirements and you are running your workloads either in the cloud or inside your data center, and your underlying network is secure or private, I would recommend Flannel. It has been battle tested by so many customers, and in Flannel specifically, the VXLAN backend. That's my first requirement. And if somebody were to use if they want hey, I cannot use encapsulation, I really need better performance, then you could use the host gateway option of Flannel. These are very simple to use, and they have been, like I mentioned, battle tested by so many other people. And
when
Calico,
you just on those, when I want to configure that, like if I want to make those configuration choices, can I make those directly within Rancher, or do I make that directly from within Kubernetes, like at the kube control layer? How do I kind of switch backends when I'm deploying a cluster?
So right now, in Rancher 2.0, we have an option. We have defaulted to Flannel VXLAN. We have defaulted to Calico's overlay of IP and Canal. We are adding support for the various other backends in Flannel in the coming releases. So, but at this point, if you want to switch to the non-default options, like let's say you want to use host gateway or IPsec, then you have to use like the kubectl and the YAML file provided directly on the Flannel website and deploy it.
Okay. So you would just go directly to Kubernetes and modify your networking there. So
correct.
So the Rancher interface makes it easier to kind of pick from these more common use cases. But if you need to do more complex configuration of the CNI, you go directly to inside that Kubernetes cluster and modify the networking at that layer.
Correct. That's at this moment, and we are definitely working on making it much easier. Like you don't have to jump out of the Rancher UI and go through the hassle of the command line and trying to download the YAML file and stuff. We are planning to support the other backends for Flannel.
Okay. And then the other question is, any comment on sort of WeaveNet or any other CNIs that come up often for you? Like
So I mean, I personally have been happy with Flannel for most of my use cases, and most of our customers have been happy with Flannel. There are like obviously few outliers who have a certain requirements. Hey, I have an existing network and I need to provide like a pod, direct routing to the pod. So in that case, it made sense to use Calico because it provides BGP support. So it publishes the routes using route reflectors and stuff like that. And I have heard good things about Weave, and it could be it also provides similar stuff, but I haven't played with it a lot. So to comment on it, but it is, I heard good things about that as well. But to summarize,
people asking questions. I mean, someone mentioned that they had heard some questions about how well Flannel scaled and how if there were network scaling issues when Flannel got into large scale deployments. Anything you've seen there would comment on that?
I mean, The scaling problems that I have seen happen not at the Flannel level, but outside of all the networking stuff. Like, the first scaling issues that I have seen is like, somebody's trying to run like 100 containers on a node that is not capable of, like, it's not beefy enough. It doesn't have enough CPU. So, there is not enough processing power, so all the processes running like Flannel is not able to get its CPU time, and it's not doing its job. So by the time we actually hit the actual networking performance limits, there are other limits which are already hit, like, there are out of resources, or, the underlying networking interface of the host is already choked, like, there is an application which is taking up 10 gig traffic and stuff like that. And from what I've seen, Flannel is definitely a good solution, and it has like proven in many deployments. It is highly scalable. It is highly configurable.
Awesome. Ben Curlis just sent a sort of a document that kind of compares some of the CNI options. So why don't we push? I just forward that out. If other people have different things they want to share, please feel free to send them in as a question. All right, Murali, did you want to go through a few more demo kind of components, or what did you want to cover next?
I quickly wanted to show, how these Flannel interfaces look like. If somebody wants to take a look at it on their setup, how they could do that. So I have these worker nodes. I just need like a couple of minutes to quickly show this. So here I have a couple of nodes running in my cluster, which are my worker nodes. So I'm on the host. I'm logged into this host, and here if I do IP adder, I can see the various interfaces. So here ETH0 is the host network, and here we can see the Docker 0 bridge, and we can see the CNI 0 bridge, the equivalent of CBR in the slides that we saw earlier. And here we can see the Flannel interface, and we can see like different weeds, like the virtual Ethernet interfaces created. So all of these weeds, they have an other end inside some container somewhere. So from looking at this output, I can tell there are like 3 containers which are using networking, from Flannel. And the next thing that I like to show is the IP route command. So here we can see, this particular node has been assigned 1042.2.024. So that's this direct connected subnet. And the other worker node, if I run the same command, IP route, I can see the direct subnet here is 1042.1.024. And if I switch back to the worker node 1 and looking at the route, here we can see the routes which are populated via the Flannel interface, like 1042.1, which is the worker node 2, is reachable via the Flannel interface. So that's how the routing happens. And if I want to see the VXLAN information, the command that I use is bridge fdb show. Here we can see the VXLAN rules for Flannel. So here we can see whatever is the IP address of the worker node 2. Let's see IP adder, and let's grab the IP address. It's 172.31.54.49. I jump back to worker node 1. This particular entry here is responsible for encapsulating the traffic from this node to the other node using VXLAN. So this is on the host side of things. And if somebody wants to check out the ARP table, the command used here is IP neighbor. We could see the ARP entries here. And if somebody wants to get inside one of the existing containers and check the IP address, obviously, this one, does it have any containers running here? Docker, yes, grep, Nginx. So I have an Nginx container running. As we saw earlier, like, the Nginx container doesn't have the tools that I need to inspect the network stack. What I do is I quickly do a hack. I run another container. It's called a debug container. I use my own image, and I use the container, the networking stack of the Nginx container that I want to inspect, and I use my own image. So this has all the tools that I need for debugging. So I run this, and then exec inside this docker exec -it e9 bash, and I can do an IP address here. So here we can see the IP address assigned to this particular Nginx part. So this is from the same subnet assigned to this particular node. So that's kind of the high level of Flannel. Cool. So I am done with the demo that I wanted to show. So if there are any questions or
yeah, that was great. You covered a ton in this. I think it was wonderful feedback from people about the depth of the presentation. There are probably 120 questions of different topics that you covered in here across so many things. So I want to make sure that we have time to jump into Alena's session. So why don't we do this? Why don't we have you transition to Alena, and maybe you can go in and look at some of the questions and respond to some of the things that people have asked. And then when she's done and we've gone through on load balancing and Ingress, we'll come back, and if people are still around, we can discuss the questions in more depth if they're pressing. Thank you. Thank you so much. That was fantastic.
Sure, my pleasure.
Alena, are you all set and ready to become the presenter?
Yep, already.
All right, so hopefully you have now become the presenter and we will be seeing your screen.
Yeah.
Perfect, I can see it.
Can you see it?
Yes, I can.
All right, let me just collapse all the windows. Okay. All right, hello everyone. My name is Alena. I'm a software engineer at Rancher. I've been working with the load balancer feature of Rancher starting in 1.6 and then slowly transitioned to Kubernetes. Today we are going to talk about load balancing concepts and how they're done in Kubernetes and how they're done in Kubernetes using Rancher. Like what are the specifics? All right, so if you think about any application, there are really two steps in deploying it. So first, you have to decide on how you want to deploy your application. You have to figure out the placement, and then you need to expose this application to the access, either within your Kubernetes cluster or from the outside. So there are several decisions that you have to make when you deploy the applications, like the network you want to choose, the scale of your application, the health check and upgrade strategies. Kubernetes has great support for all of them. But when it comes to exposing your applications, you have to be really thoughtful about how you want to expose your application. What are the consequences of exposing it one way over another? The first solution that comes to mind is you can just publish the port to the host and your application can be accessed via it. You publish it on port 80 and then the traffic flowing to the port 80 goes directly to the pod. So it might seem easy, but then you realize that you need a load balancer after all. And why do you need a load balancer? As Murali mentioned during his presentation, the first key is you have to give a user an access to a reliable entry point. And there can be several pods behind this load balancer entry point. And if one of them dies, the load balancer will redirect the traffic to another pod. Then there is a load distribution where you have to evenly place the load on your backend servers. Then the load balancer can be useful when it comes to the SSL of load, where you kind of think about it the traffic comes to load balancers encrypted, and load balancer is the place where you store your certificates, or you grab them from service like Let's Encrypt. And then you decrypt your request, and then you route it to the backend servers. And then another one is the hostname-based routing is another useful feature of the load balancer, where you can have a one global load balancer across your for your applications, and then depending on the user request on the hostname and path, you can decide to which backend server to redirect the traffic. The load balancer can be also helpful when it comes to the blue-green and canary deployments, where again the load balancer acts as the entry point to your application, and then you can replace the old application with the new one. So load balancer is very heavy in features. And now we're going to go over the load balancer concepts and how they're done in Kubernetes. Unlike whoever is familiar with Rancher 1.6, when we had just one load balancer and it was handling both internal and external traffic, in Kubernetes there are several ways to do the load balancing. The first way is the easy one, is the internal load balancer with the cluster AP service. So the cluster AP service is, here is the YAML spec that you use to create it. Here you say, this is my service name, and this is a selector. Based on this selector, the backend pods are going to be chosen for traffic redirect. And here's the port that you open on this cluster service. As a result of the service, you're going to get the cluster AP back. And once you hit this cluster AP, there's a service called kubeproxy that handles the load balancing to the appropriate backend pod. The default load balancer algorithm is round robin, but you can change it. That's the internal load balancer. When it comes to the external load balancer, there are actually several choices. Actually, there is a mistake here on the slides. It's an external L4 service. And it's done via load balancer Kubernetes service. Here is the service definition where you define the rules on how you want to distribute the traffic, which port and which pods, but this is just a service definition. The implementation actually varies, and it depends on the cloud provider that is backing up your Kubernetes service. If it's a GCE, there can be one implementation. If it's Amazon, it can be another implementation. So here on the slide, I've covered how it's done on the Google Cloud Compute Engine. So basically, first you deploy your workload with a several number of pods, and then you create your load balancer service definition. And what happens behind the scenes, there is a cloud provider code that is baked into the Kubernetes repo, and like it knows which cloud it runs on based on the parameter that you pass when you create your cluster, and then it knows, all right, this load balancer service has to be programmed on the GCE, although the service definition doesn't say, doesn't give this direction, but it knows based on the cloud provider choice. And then what it does, it actually programs the LB in the Google Cloud, and with the rules, with the firewall rules, allowing traffic flow to go to the GCE nodes. And again, this cluster has to be homogeneous. It means that all the nodes have to belong to the GCE. And that's layer 4 traffic. You cannot specify any hostname routing rules here. The only one thing that you can, I think, configure is the inbound port. And at the end, once the Google Cloud provider configures the Google Load Balancer, you'll be given this Ingress IP address that you can use to actually access your application. So that's layer 4 load balancing. Now configuring external L7 load balancing via Ingress. Ingress is another resource in Kubernetes. And here's the example of YAML Ingress definition, where you define the rules for your load balancer. And similar to load balancer service, the implementation of Ingress varies on the Ingress controller. So Ingress controller is the term used for the code that is backing up the Ingress resource. So when the user creates the Ingress, there's going to be a controller that runs in Kubernetes cluster. It can also run outside of Kubernetes cluster, but the most common practice that I've seen, it runs as a native Kubernetes application. It listens for the Ingress resource creation, and it configures the load balancer that also depends on the Ingress controller definition with the rules allowing traffic to be distributed between the backend applications. So here, if you look at the Ingress definition, there are hostname routing rules configured saying that if the request comes with the path foo for the host kubernetes.io, it should go to foo service. If it comes to host kubernetes.io with a bar path, then it should go to the bar service. That's the basic of the hostname routing. Now, let's talk more about the Ingress controller implementation. Ingress controller is something that the cluster administrator deploys on top of the cluster. For the cloud providers like EKS or GKE, the Ingress controller comes as a built-in. You don't have to turn anything on. So here's an example of Amazon EKS implementation. So Amazon EKS Ingress controller configures the ALB on the Amazon cloud, and then this ALB will forward the traffic to the EC2 nodes based on the path. and the host, like user domain com website or user domain com.chat, will be forwarded to the different services. It can be done like the traffic can be forwarded cross nodes depending on the load. The Ingress controller for EKS runs as a native Kubernetes application, means it gets deployed as a pod in Kubernetes cluster, and it listens to Ingress create update events, and whenever Ingress gets created or updated, the ALB gets configured accordingly. So that's an example of LB outside of Kubernetes cluster. And there are several, like I keep on getting questions about like how do I manage the traffic for, how do I load balance traffic if I have a cloud provider like F5 or NetScaler? There are several Ingress controller implementations for external cloud providers like OpenStack or Google GSLB, ELB, NetScaler, F5. There are many more out there, but I've just listed the basic ones. So I've given a link to the GitHub repos where you can actually find the details of the Ingress controllers, and you can find, like on the links, you can find the way to deploy them as a native Kubernetes app. Then Ingress Load Balancer can also run inside Kubernetes cluster. And one of the examples very commonly used is the Nginx Ingress controller. Nginx Ingress controller gets deployed as a native Kubernetes app, and it acts as a controller, meaning it listens to Ingress create update events and program the load balancer accordingly, but it programs itself. So it itself runs as a load balancer. So whenever Ingress user creates an Ingress or updates an Ingress, Nginx Ingress controller programs itself. And how this Nginx Ingress controller gets deployed, it's only up to the cluster administrator. But again, the most common example is when Nginx Ingress controller gets deployed as a daemon set, meaning it runs on every node in the cluster, and it exposes itself as a node port service on ports 80 and 443. Then the request would come to the node IP and node port, and it will have like a certain host name and path. And based on that, Nginx Ingress controller will redirect the traffic to the backend user application. The Nginx Ingress controller deployments can vary. Like, for example, it can choose to expose itself via the load balancer service if your Kubernetes cloud provider is public. But node port service is another common way of exposing itself. So there are several Nginx Ingress controllers out there, and again, I've listed just the most popular one, like Nginx HA Proxy, Traffic, and Contour, and you can really choose which one you wanna deploy. By default, in Rancher provisioned Kubernetes clusters, we use Nginx Ingress controller, but you can disable them in favor of HA Proxy, Traffic, and Contour. There is no built-in support yet in Rancher UI to actually choose the provider of your choice. You have to do some manual step that I'm going to demo later, but nothing prohibits from disabling it and enabling the provider of your choice. Now, there is a one thing that seems to be missing from a lot of online demos about when it comes to the load balancer. So it explains how hostname routing is done on the load balancing, and it kind of assumes that the request is going to come having like website example.com, and then this request hits like a node port on node IP and port of the Kubernetes node. But who actually programs the external DNS with the entries of the Kubernetes node IPs and ports? Because it is not done. It is not done automatically. So usually you can if your Nginx Ingress controller is exposed as a load balancer service, for example, and your provider is Amazon, then you can configure your DNS with the ALB entry point. Or if it's a node port service, then the DNS has to be programmed with a node IP addresses where your Nginx Ingress controller is deployed and exposed via the node port service. This process can be either manual or it can be automated. So it can be automated in a way that there can be a controller that actually watches the Kubernetes clustering nodes and automatically programs the DNS with the IP addresses on the nodes. Today, we don't have that built-in support for that in Rancher, but there are several solutions out there that you can implement. Now, that's a fun part. We're gonna do the live demo. I'm gonna do the live demo for several use cases of the load balancing. But then we're going to return to the slides where I'm going to demo more like examples of the use cases, how for example, internal load balancer can be integrated with the external load balancer. I'm going to give a couple of examples of that, but let's go to the UI first. So here I have my setup. I have two clusters. One cluster is GKE, and another one cluster is I called it RKE, but it is actually the cluster deployed on DigitalOcean, and it uses our own tool called RKE. This is a tool that allows you to deploy Kubernetes cluster on any cloud provider, as generic as it is. And when you deploy a GKE cluster, you're not given a choice of what Ingress controller to use. So by default, GKE comes with the Ingress controller that is meant to program the Google load balancer with the load balancing rules. And then for the RKE comes with the Nginx Ingress controller that gets deployed as a daemon set and exposes itself as a node port service. So I'm going to give a quick overview of how you can actually see this Ingress controllers. So in the UI today, we do not display the system services. It's something that we're going to enable in the future release, but you can, it's some networking error. So something is going on. Let me try my backup cluster. Right, it's an RKE and GKE, similar to the cluster that I've shown before. So I'm going to open them in a separate tabs. So every cluster can be accessed either using the Rancher UI, or you can access it directly using the kubectl. You can launch the kubectl client in the UI, or you can go via the kubeconfig file. So here, hope it's large enough. Get deployment. So the kube system is a namespace where all the system services usually get deployed. And here you can see the DNS plugin that it's a Sky DNS on the GKE. And then here is the GKE Ingress controller. It's a L7 default backend. And on the RKE, it is similar. Yeah, so you can see the deployment here in the kube system. I bet the Ingress controller might be on the different namespace. So I'm just going to list them all. Yeah, so it is an Ingress Nginx. It has its own dedicated namespace for itself. So let's get started with the demo. First, we're gonna create the workload, and we're gonna expose it internally using the cluster IP service. So it can be accessed within the cluster. In Kubernetes,
the Rancher UI to do a lot of this, but you could do all this directly from kubectl as well, right? I mean, there's no reason you have to use the UI.
This is right. If you prefer to use the CLI, you're welcome to do so. We're going to display all the resources that you create using the CLI and the UI, just for the complete user experience. But I'm going to explain like some nice extras that we do if you deploy your application using Rancher UI. So for example, I'm going to deploy my server application And I want to deploy 3 pods behind it. I want to deploy it in the namespace. So in Kubernetes, if you go natively via the kubectl, in order to deploy the workload and to expose the workload via cluster IP services, you have to create 2 objects. So first you have to create the deployment, and then you have to create the service. So it's done explicitly to expose your deployment to the outside. In Rancher UI, we wanted to simplify this user experience by letting the user to actually choose the port when he deploys his deployment. So here, this is the port on the container, and this is the protocol. And I want to expose it as a cluster IP. And I choose option same as the container port. And once you click launch, what Rancher does, it will execute these 2 separate calls on the backend for you. It will create the deployment, and it will create a cluster IP service for you. Just gonna show how it looks like. So here's my server deployment, and it has 3 pods. All are available and up to date. And here's the services that here's the service that we've created for our service deployment of type cluster IP, and it has a cluster IP assigned to it. Now, let's demo on how do you actually, just to prove that the load balancer, internal load balancer works, I'm going to create a client application from where I'm going to do the request to my server application. Docker client. Right. This is just a simple client with useful tools like curl that I'm going to use. And here, I'm actually going to use the cluster IP 1043.12.243. What's the IP address? 12.243. All right, so the name change means that we are hitting a different server. So a different server and the server application give me the different name. So you can access your server internally using the cluster IP, then it will balance the traffic for you. But also you can you can hit it using the DNS name, which is also going to be the server. Another useful thing that Rancher does for you, because although most of the clusters come with a built-in internal DNS support, like either via SkyDNS or Core DNS, you still have to create a service for your workload in order to expose it to all the other workloads in the cluster. In Rancher, we do it automatically because we realize that DNS is such an essential feature. A user doesn't have to do this, extra step in order to get the DNS resolution for his services. And another nice feature is like you can create something using the Rancher UI, and you can actually view its representation in Kubernetes terms by view YAML file. So you can view like how this resource is presented in Kubernetes. It has all the definitions that you've passed in during the creation, as well as the status of your resource on the Kubernetes side. You can save, you can make changes and save it. You can, download this kubectl, download this YAML file and apply it later using the kubectl. So it is really up to you. And another useful thing that I wanted to demo is, so here you can see that you get your cluster IP service, right? This is your cluster IP. But if you do one more command, get endpoints is the resource that gives you actually the endpoints for your cluster IP service. So it means that when you hit this 1043.12.243 IP address, the kube proxy will redirect the traffic to one of these IP addresses that actually belongs to the pod of your server application. So that's the external load balancer. Now let's dive into the, this is internal load balancer. Let's go to the external load balancer. So because in most of the cases, you need your application to be exposed to the outside world. And let's first cover the L4 load balancing. So first I want to mention that L4 load balancing is not enabled on every cluster you create via Rancher. It is only enabled on the public cloud providers like GCE, Amazon. So let's actually go over it. I'm just going to show where it's enabled. Oops, not this one. This is a bad demo. So it's going to be enabled here on the GKE, on EKS, on Azure. It's going to be enabled on the EC2 as well, where we provision the cluster using Archie, but it will only be enabled when you choose the cloud provider, Amazon. Only in this case, we pass this flag to the Kubernetes, API server, notifying that the AWS cloud provider has to be turned on because it's an AWS cluster, and only then the load balancer will be functional. So now let's create something. Let's create an L4 load balancing in our GKE cluster. So first, let's kubectl. Here, let's go to the project view and GKE backup. We already have our server. Let's remove the server. Let's create it again. Behind Adobe. So similar to our cluster IP, we define the name, we define the scale, we define the image, and we define the port, which is the same port 80, but the way we're going to expose it is different. So we are not choosing the cluster IP, but we are choosing the layer 4 load balancing. And I'm going to choose a different listening port, like I'm going to choose some 30,000 port. All right, and what's actually happening behind the scene is Rancher is creating the deployment, and it is also creating a load balancer service. Let's look into the Kubernetes side of things. Okay, so here's our load balancer service, and it's of the type load balancer. It also has a cluster IP, and it says pending. Pending means that it's still programming the rules to the Google load balancer. So once the programming is done, you should see the external IP address here. You can also see the service under load balancing tab. Oops, not yet. Looks like it's some leftover ingress that I'm going to remove for now. All right, so now it is programmed. You see 35, you see the IP address of the Google load balancer. That's a load balancer that you have to hit in order to reach the Kubernetes cluster and the application that runs in the Kubernetes cluster. And another useful thing that we do in Rancher, we actually give this endpoint back to the user on the workload view. So like he doesn't have to go to the service to figure it out. Like first he has to figure out which service exposes his application, and then figure out the IP address from there. In Rancher, we just place it directly on the workload. All right, so let's hit our name.html. Okay, here we go. Let's actually do it via curl just in case. All right, so the Google Load Balancer balances the traffic for us. And what is this? If you are curious on how it gets represented in the Rancher API, this endpoint that you're hitting here, you can use some useful feature of Rancher UI, which is called View in API. So here you can see the Rancher resource representation in the API. And the public endpoint is the field that keeps the address of the load balancer service. And once you, like if you hit it, you get redirected to the workload. Right. And similar to the cluster IP, you can actually, you can see it here, like you can view edit YAML here as well. So this is a layer 4 load balancer that again gets enabled only on the cloud providers like Amazon, Google, Azure. And now let's cover the L7 load balancer using Ingress. So let's switch to our RKE cluster. And in order to configure Ingress load balancer, you have to go to the load balancing tab. I believe we already have our server workload. So let's add an Ingress. In the Ingress, when it comes to the rules, we're actually very flexible when it comes to the host name definition. You can either specify which host name to use, like in order to redirect your traffic only when the request comes with a particular host name. But then it is up to you to program the external DNS with this host name as a DNS name and the node IP as a target. Or we can generate the random host name for you. There are certain limitations to this approach, but it is very nice for the demo purpose. Like let's do it. So we know that our application has a path named .html. And here I'm choosing my server as a target, and I know that my server listens on the port 80. So when I hit save, the Nginx Ingress controller behind the scenes starts programming itself with the server targets. And in the end, similar to the load balancer L4 service, we should be given an endpoint that we can hit and be redirected to our application. But that's doesn't look like it is programmed yet. And let's look at how it looks like on the back end. So this is our RKE cluster. This is our Ingress resource. Here we go. And you can see that the host got generated. It has an Ingress name, it has a namespace in it, and then the IP address of the host is IPIO. So, and if you hit this in the UI, like this name HTML, you get redirected to your workload. And the Ingress Nginx Ingress controller will balance it for you. You can actually view Ingress definition from the UI as well by edit YAML Ingress. So here you see how it looks like on Kubernetes. So there's a specification where you define the rules, where you define the paths and the backend. As you might have noticed that here, when you add an Ingress, you actually specify workload as a target, but when it gets translated to the Kubernetes, it becomes a service. That's another Kubernetes quirk, that it does not let you to pinpoint Ingress to your workload directly. It has to be done through service. So basically you have to create your deployment first, then you have to create your cluster IP service, and then you have to use the service name as an Ingress target. In Rancher, we make this job easier for the user, and we actually do a lot of things automatically, like creating the service name based on the workload that is passed as an Ingress target. Now, let's go back to Ingress and let's demo one more feature, like SSL certificates. So you can use your Ingress as an SSL offload point. So basically, your certificates will be stored. Your traffic will come as encrypted to your load balancer, and then Ingress controller will use the certificates to decrypt the traffic, so it sends us plain HTTP traffic to the backend. So somebody asked whether we have Let's Encrypt embedded support in our UI API. Not yet. The only certificate that you can use today is the ones that you create using Rancher UI, but we are looking at the Let's Encrypt support at the moment. So let's demo on how to actually deploy how to actually add the certificate. So you should go to resources. So like once you're in the cluster, you should go to resources, and then here's the secrets tab. And that's where you add your secret. Actually, no, not secret, certificate, sorry. Certificate. And you can either make this certificate as available to all namespaces in the project, or available to the single namespace. And now, as I mentioned, project, I just want to explain what project is. It's Rancher concept. It's actually, you should read it as a group, namespaces grouping. Some resources that you want to limit only to a particular set of the namespaces, that's what project supports. Okay, let's do our secret only available to the default namespace, and then you read the certificate from the file. Let me just change certificates. I download the key. I download the cert. Ew, don't like it. I don't know why it doesn't like my private key. Let me try the other demo server that might be back online. Please work, because there I have the certificate enabled.
Alena, while you're switching between that, there was a question about, David asked, are the certs stored in Kubernetes secrets? Is that where the actual certs get stored?
Yeah, they're stored in the Kubernetes secrets. And let's say you choose to, like, you create a secret and you choose, okay, I want to make it project scope, and your project has 5 namespaces. We are actually replicating the same secret to all the 5 namespaces that are behind the project.
So if somebody wanted to use like Let's Encrypt or import a certificate from Vault, would that be pretty straightforward? How would you do that?
I would probably do it using the kubectl, because we don't have any built-in support in Rancher. Or you can, like, I think we do discover the certificate that are created natively, but that's something I need to check on. Cannot say off the top of my head. Okay, so yeah, looks like my original setup is back online, and here I already have a certificate created for my Ingress. That one I can use. The load balancing at Ingress, and here you can choose whatever certificate you actually created using the Rancher UI. And then, similar to the previous example, we just define the hosting routing rules for your backends. You just set up the host for your certificate as well. There were actually several questions about, like, how do you, like, by default in all the clusters provisioned by RKE, we deploy the Nginx Ingress controller. Is there a way to deploy any other Ingress controllers, or other ways, like, to replace the existing Ingress controller once it's deployed? So in the future, we are planning to give user a choice of what Ingress controller provider he wants to use in a particular cluster as an option during the cluster provisioning. But today, there is a workaround on how to do that. So the first one would be, you have to delete the Ingress controller deployed by RKE. It gets deployed in the Ingress Nginx namespace. So you just delete this namespace, but that alone is not enough, because next time the cluster changes, the RKE will actually redeploy the Nginx Ingress controller. So we have to disable it by going to the RKE cluster, going to the cluster view, then hitting edit. And then where is our cluster options? And here's the button, edit as YAML. It's where you can see your cluster representation in the YAML format. It's here where you can change your provider definition. So note that none of the providers besides Nginx are supported by RKE at the moment. We just evaluated the Nginx, but let's say HA proxy comes as a replacement or as an addition. They're going to be HA proxy as a provider here. So if you want to design today, you have to actually pass as none. Have to pass provider as none, and then hit save. It should actually remove the provider from your cluster, and then you have to deploy the Ingress controller manually, either using the YAML definitions and kubectl, or if you export, or if you have a Helm chart for deployment, you can use that as well. Another thing is, today Nginx Ingress controller exposes itself as a node port service on every worker node in the Kubernetes cluster. And let's say you just want to run it on a particular set of nodes that are labeled in a certain way. Here is the example of how you can pass the node selector. For example, like, I want to run my Nginx Ingress controller only on the nodes that have a label up Ingress, and it will be deployed just there. So, okay, that's it from the UI demo side. And Shannon, do we still have time? I want to go back to the slides and actually list a couple of use cases there.
Given the fact that there's 50 questions, I think go ahead, go through it. We'll cover it. You know, I think everyone knows we record these things, so if they need to leave, no problem. But yeah, we still have more than 300 people hanging on every word, Alena. So fire away.
Okay, so I wanted to go over some real life LB examples where actually Nginx Ingress controller plays or any other Ingress controller can play a key point. And the first one that comes to mind is a Rancher 2.0 HA install, where we actually use the Nginx Ingress controller in the Kubernetes cluster to do SSL termination for the Rancher server. Okay, so on this setup, there is some layer 4 load balancer TCP, which is a public load balancer. And there is some external DNS that forwards traffic from rancher.yourdomain.com to the layer 4 load balancer. Then the layer 4 load balancer, this external load balancer, has to be programmed with a cluster node IP addresses where your Rancher server gets installed in HA mode. And then it will know to forward the traffic to one of these nodes. And then the traffic comes as encrypted to one of your nodes, and then Nginx Ingress controller will terminate your SSL connection and forward the plain HTTP traffic to Rancher. And today in the Rancher HA install, nodes that are added to the L4 load balancer are added manually because you know in the beginning like which nodes you want to deploy your Rancher server to. But let's say you're deploying a similar application where your set of nodes can change. Like for example, there's some auto-scaling logic behind it. So then I would suggest that this process is automated. The process of watching the Kubernetes nodes information and updating the DNS accordingly. Okay, so Rancher 2.0 HA is one of the examples. Now, the example of Nginx Ingress controller, they actually exposed VLB service on EC2 cluster. So in Rancher Archi setup, Ingress controller is exposed via node port service, meaning that you need to hit one of the node IP addresses, or your DNS has to be programmed with one of node IP addresses in order to reach the Nginx Ingress controller. In this case, as it's a EKS EC2 cloud provider, and Nginx is exposed to the outside using the load balancer service backed up by ELB. It means that the DNS of your choice, in this case, it's obvious to choose the Route 53 as also AWS, gets programmed with a single endpoint, which is the ELB. So the user traffic will come to Route 53, then ELB will forward it to the Nginx Ingress controller, and Nginx Ingress controller will distribute the traffic between two applications based on the host name. And again, like Route 53 can be programmed with a wildcard, like example.com in this case, if that's the only Kubernetes cluster that handles the traffic to example.com. That's again a single cluster setup. And then here's an example of multi-cluster setup. I've picked this example from some online article that's been released several days ago about the Cloudflare. So here we have two Kubernetes clusters, one GKE and one EKS, and they have the same Nginx application. On the GKE, the app exposed is exposed via Ingress. That is again is backed up by Google Load Balancer. And on EKS, it is exposed via the load balancer, ELB1 load balancer service. That's an endpoint that forwards the traffic to the Nginx service. Then the Cloudflare DNS gets configured with the geo routing support, and you can say, okay, I want the traffic from North America to be forwarded to AWS cluster, and from Oceania is forwarded to the GKE cluster. So this load balancer DNS is powerful in that way. So that's an example of the multi-cluster support. And that's it from my side. I'm open to any questions if you have any.
There are so many, Alena. I'll try to kind of go through some of the ones that have come in during your presentation, and we'll kind of go through. One of the questions somebody had was, if you're running on bare metal, is there a way to protect ingress traffic from like denial of service attacks? Anything you'd point to there?
I'm not sure if Ingress controller itself has any sort of protection, but I will look into it. That's an interesting question.
Another question that came in is, you know, so this is a question that Nicholas asked. He said, is there any way to expose a service via load balancer running cluster on premise? I always have to change all my Helm charts or catalog offerings from load balancers to node port. Is there no way to kind of like globally configure that?
Unfortunately, no, because the load balancer service support is actually embedded to the Kubernetes binary. So it is a part of the Kubernetes. It's not like Ingress controller that can be deployed as a separate application. So in order to, let's say you have your, like you're working on implementing your own cloud, right? And you want to add a load balancer to it, you would actually have to go to the Kubernetes, you have to fork it, and you have to implement your cloud provider as one of the options. I know that they are working on adding the outside cluster provider support, where you can actually run your cloud provider code separately from the Kubernetes binary. But I'm not sure if of the status of this project. So today, there is no easy way to do it.
Okay. One of the questions was asked. Drew asked if it was possible to kind of change the configuration of the default Nginx ingress, like to change the settings on it. So if I want to, like I'm using Nginx, how do I change the settings on that Nginx?
Yeah, it is possible. So like how Nginx controller works, it actually you can configure the config map with the custom parameters for Nginx Ingress controller. This config map will probably have some name that Nginx knows how to locate, and that's where you pass the parameters that are not a part of the original Ingress definition, but the parameters that only Nginx Ingress controller would understand. So Nginx Ingress controller will look up for this map, config map, and it will apply all the custom parameters that we have provided as a part of this config map to the Nginx Ingress controller.
Okay. Couple more questions that would probably be worth one. Is one that Ben Curlis asked. He said, do you have any thoughts on using Ingress controllers versus using kind of API gateways like Ambassador or Kong? And any thoughts on that, and when you might use one versus the other?
I'm not really familiar with the Ambassador, so yeah, I'm afraid I don't have an answer to this question. Okay. Something that I have to research.
Okay, no problem. And then, Murali, are you still on as well? Can you take a few questions, because we have lots of questions that came in for you as well?
Yeah.
Okay. One of the questions that, well, actually this one's for Alena. Alena, Randall asked, he said, Metal LB is a project from Google that can do load balancing on-prem. Have you had any experience with that, or do you know of anyone using that project?
I have not tried it. What Kubernetes resource does it back up? Is it for load balance, or is it for Ingress?
I'm not sure. I think it's the whole idea is to have a sort of load balancing on-prem type of service that would be deployed.
The thing is like today, the Ingress is flexible, so you can choose like whatever Ingress controller you want to run separately. And yeah, for the load balancer, I don't think there's much flexibility.
One question also is, we talked about storing keys in Kubernetes secrets. Do you know if the Kubernetes secrets are encrypted?
I think they are.
Okay. The question, one of the questions, Murali, that I think might be, was kind of, and maybe it's a question as much for Alena, but how do you compare, kind of service discovery, or sorry, not service discovery, but Istio and service mesh with using kind of load balancers, and do these things sort of overlap, work together? There's a lot of questions about, service mesh, and I know we're going to talk about it in our next month's meetup, but maybe you can just kind of talk about how Envoy, Istio, these services kind of complement the load balancing and networking functions we talked about today.
I'll probably pass it on to Alena. She's better at this topic.
Sure. So the service mesh gets deployed a little bit different from the Ingress controller. So the deployment is how it differs first. So if Nginx, if Ingress controller actually runs as a separate application, as a separate deployment, the service mesh runs as a sidecar to your deployment pods. That's the first big difference. Second is like it gives you the load balancer, but it gives you much more capabilities like monitoring. There's a monitoring layer that actually lets you monitor whatever happens to all the traffic that go through the service mesh to your backend applications. It can actually tell you, it can show you like the spikes. It can show you the like a CPU memory usage and stuff like that.
Got it. So one, when someone, there was a couple questions about, kind of DNS. So I think you covered a little bit here, but one of the things I remember from in the past is often there were sort of integrations between, like Hans asked this. He says, although we don't use ELB but point directly to Rancher HA proxy load balancer, the endpoints are automatically created in Route 53. It seems like that's different now, and how is that changing kind of as with sort of Kubernetes?
Well, yeah, it is different, but it shouldn't be hard to implement in 2.0. So like the way it worked in 1.6, so we had a load balancer service exposing on the Rancher hosts, like Kubernetes nodes, and then there was a external DNS microservice that listened to the load balancer service creation events, and it was programming the DNS provider of your choice, like Route 53, any other cloud provider DNSs, with the IP addresses of the nodes where the load balancer service is exposed. It should not be hard to add a support for that in 2.0. Only instead of listening to the Rancher load balancer events, it would listen to the Kubernetes node pod services, load balancer services, and it will program the external DNS with the endpoints of the node IP addresses.
Got it. One thing too, I get lots of questions during this that are kind of specific to an environment, like I'm trying to do X and it seems to not be working. It's really hard, obviously, to troubleshoot during these sessions, guys. So if you are kind of having an issue, feel free to email us. Like Alena, Murali, and I all are available on email. Just Alena at Rancher, Murali at Rancher, Shannon at Rancher, and we're also all on the Slack channel, slack.rancher.io. So if you're running into some issues, please kind of connect up. Okay, so why don't we do this? Why don't we wrap up the presentations for a minute? There are still lots and lots of questions. I'm just going to go through a couple things before we wrap up, and then we'll come back to some of these questions and see if we can answer them. But with that, Alena, thank you for the presentation. That was absolutely great and really spot on. So just to kind of, I could tell from the questions that lots of people are still getting up to speed with Rancher 2.0. It's pretty new here. We've just released it in April, beginning of May, and so there's a lot of people I think that are kind of trying to get your hands on. If you haven't already, getting started with Rancher is really easy. You can set up a host in really anywhere. You don't need a ton of capacity. And then just use a Docker run to set up a single node implementation of Rancher, and from there you can start provisioning. If you do need to set up HA, there's docs on that. We're still working really hard on the docs. 2.0 is pretty new. It's a major change from 1.0. So if you've been struggling at all with the docs, we're working kind of very hard right now to improve the docs on 2.0. But feel free to help if you see things that are wrong. It's all open source docs. It's all in GitHub. It's all, this whole thing is a big open source project. So any help you can provide on documentation and tightening things up is enormously appreciated while we continue to work on it as well. The place to get started though, if you are looking for the docs, is just docs.rancher.com. The other thing you'll see is if you're just trying to maybe if some of this is new to you, I know there are a lot of people who are new to Rancher or kind of trying to get it out. We run weekly trainings right now for 2.0, where we'll have a couple engineers on and spend an hour and just go through the basics and answering direct questions. We typically have hundreds of people on those as well. So please feel free to join any of those. You can register just by going to rancher.com to get involved in those trainings. And like I said, Rancher is open source, Rancher OS, RKE, everything we build, we make available. So, please, feel free to get involved. We absolutely would love to have more external contributions, especially in areas like docs and everything, in addition to issues. So please don't hesitate to get involved at the Git level. So with that, I'll just sort of say thanks to all of you for attending. We've had a fantastic turnout as always, and then I'll start to go through some of your questions and answer them out, and turn it back over to Alena and Murali to answer as we go. Okay, guys. So why don't we jump into some of the questions that have come in over the last couple hours and see if we can address some of the other things that were asked. So one of the questions that came in earlier today was, there was this question was, by default, Kubernetes limits 110 pods per node, or per node, or there's some best practices to use the /25 as the default sitter per node. Murali, does that make sense?
Yeah. So I'm looking at that question. So
okay,
so there is a disconnect between the number of pods and the subnet seeder. So that and I recently raised this issue. So this can be fixed on the upstream by a PR. I just didn't get a chance to push it there. So it's not exactly like it's a best practice or anything. It really depends on your use case. Now, let's say if you are planning to run heavy workloads on a single node, and you know that they're going to take up a bunch of CPU resources and memory, you're planning to run like probably, let's say 20 or 30, then you would choose the subnet size based on your needs. So it's a best practice that would it's recommended as 110 because it would solve majority of the use cases, but it's not a hard and fast rule.
Great. There's another question Ramon asked earlier. He said, what he was asking about, like low latency networking, and if you needed to do gaming and other things, what type of recommendations would you make, Murali, for people who wanted to build a Kubernetes cluster, and where should they be worried about latency? What are some of the approaches that might help with that?
If somebody is really worried about latency, the first thing is like you have to design your underlying network properly. So the first thing is like, can you use bare metals instead of virtual machines? That's the first step where you could cut down some of the latency. Next thing is like, how big of network interfaces can I assign to this bare metals? And then after that, is it possible to set up my underlying network to use a direct routing, like instead of using overlay? That would cut down more latency. And the next step is, the containers, when they're actually running, are they getting enough CPU power, enough CPU resources to run in the correct time frame so that they could respond to the request? How do I tune my servers so that I can configure my sysctl settings for enough contract tables, enough ARC tables and stuff like that. So you need a bunch of tuning to make sure your cluster is ready for your gaming purposes. So there are a bunch of tuning things that need to be taken care of.
Okay. Another question came in from Scott, and he said, some services like Kube2 IAM, which is used on AWS Millions, require you to know which networking provider you're using, since the app creates IP table rules on each node. And then it needs the network provider's interface. For Canal, which provider, Flannel or Calico, is acting as primary? And do you want to maybe answer that, Murali?
I got the last part. Like Canal uses Flannel as the networking plugin with the Calico's network policy enforcer. That part I got. I couldn't understand the previous one.
Yeah, so it sounds like the right answer is the core thing. When you're using Canal, you're using Flannel. Flannel is what the actual interface is.
Correct.
Okay, great. Another question, and this one, maybe something, Alena, you can ask. Dustin asked this a while ago. He said, besides traffic, Are you looking into Fabio by chance as a load balancer ingress controller? I know it uses console instead of etcd. Have you ever heard of or looked at Fabio?
We have not considered Fabio as our provider choice. We were more looking at traffic, Nginx, HA proxy, but I'm gonna look at it as well. So it's like if it can be deployed as a native Kubernetes application, then there shouldn't be any problem. But you've mentioned that instead of etcd, it uses something. Shannon?
He was just saying he's using console instead of etcd as sort of a data.
So yeah, so the point is like as long as it can be run as a native Kubernetes application, we can enable anything on our key provision clusters. If the Fabio can be installed this way, then yes.
Okay, great. And then there was another question. This one was from Anton. He said it was, in the case of traffic, one of the concerns he had was, how fast is it, especially around encryption? He was saying, I know it's written in Go, and because of that, its libraries for encryption are typically slower than sort of Envoy, HA proxy, Nginx, which are written in C++. Is that something that we've looked at, or do you have any idea about performance difference between Nginx and traffic and HA proxy?
We're gonna run the performance test once we bring more cloud providers into the equation. That's where we're gonna compare the results and give the recommendation to the users of what to use.
Okay, but in general, the idea is, as time goes on, you're expecting to be, making it easier and easier for people to select between more and more different.
This is right. Yeah, you won't have to do all these manual hacks that I've demoed, like disabling it in the cluster YAML spec. You would be able to choose it when you actually deploy your cluster.
Yeah, there's a couple of things I think that would be helpful so Martin asked a question that was very good. He said, what level of isolation does each of these different networking CNI plugins provide between namespaces? Can you talk about that, Murali, and just kind of discuss how, what isolation is like between namespaces and how the networking layers?
Sure. Yep. I can definitely talk about that. So by default, if you are using a Flannel plugin, right? There is no kind of security groups or isolation provided between the namespaces. And if we use a plugin like Calico or Canal, for example, right? So if we are using Canal in Rancher 2.0, what we do is we have this concept of project, and we install network policies, by default to enforce isolation between different projects. What it means is namespaces within the same project can communicate with each other, but across different projects, they cannot communicate. So this enforcement is done it's a two-step process. The first step is you have to specify the network policy, which is based on your needs. And the second thing is you need a network policy component to enforce these rules. So for example, if you have Flannel, we have Rancher 2.0 takes care of step 1, but the step 2 cannot be taken care of because there is no component running. But in case of Canal, you have this network policy controller that is running that will enforce these rules. So that's how we provide the isolation between namespaces.
So there was a question that David asked just now. He said, well, then does a project equal a namespace, or is it, maybe you can just talk about what, Alena mentioned this earlier, but basically a project is a collection of namespaces, and maybe you can talk about how that sort of, what projects exactly are.
Okay, so we in Rancher 2.0 we came up with this user experience based on the real life scenarios. Usually what happens is in an organization there is a project, and this project usually has like a bunch of teams or a bunch of different applications. So they need to work together closely, and we want to kind of provide a little bit of isolation, and at the same time things that they want to share. So a project is a group of namespaces. Now, let's just for example, Alena and I are working on a project. So what we would do is Alena gets her own namespace. I would get my own namespace. I deploy my applications in my own namespace. But at the same time, I can share my service with Alena so she can develop her stuff. Like if she's, let's say, working on a front-end application, I'm working on back-end, I push my code in my namespace, but Alena can still access it because she's part of the same project. But think of it in a production, like if you have two different projects, one is running one business unit's production application, the other project is running a different PU's web application. You don't want them to communicate with each other, so you would deploy in two different projects. So that's the kind of user experience we wanted to provide. So to summarize, project is a bunch of namespaces. You can create how many ever you want, you can delete from the project, and within the project, the namespaces can see or communicate with each other.
Awesome. Murali, thank you for walking through that in so much detail. One other question about sort of CNI plugin. So Diego's asked, he said, if when I use a CNI plugin, is kubeproxy replaced by the chosen plugin, or does that stay the same?
I believe the kubeproxy remains the same for Flannel and Calico. So maybe if there is like some specific network plugin that has a different behavior, I could take a look at it. But at least the ones which I've used, I think they don't replace it. Okay.
So this is a question that Jacob asked a while ago that I think was useful, and it was kind of, and you may have covered most of it already in your last answer, but he said, it's not, I know it's not part of the agenda, but can you go over the network policies that Rancher creates automatically? What rules, when are they created, etc.? I know it's generally project isolation, but it seems there are certain default policies for Ingress, etc. Anything where this is documented, you can point Jacob to or other people to that are trying to understand, if I'm using Canal, and I know we've made Canal the default up till now in the 2.0 stream, what's being set by default around network policies?
I see. So as I mentioned earlier, the user experience that we wanted to provide, the kind of isolation that we provide is at project level. The project is a Rancher concept. It is not a Kubernetes construct. So for that reason, when a project is created in a cluster in a Rancher UI, we create a bunch of network policies by default. What these try to do is they try to enforce the rules, like across projects, namespaces cannot communicate with each other. Within the same project, the namespaces can talk to each other. So for that, what we have is, let's say, one network policy. The way it looks like is, apply this network policy to all the containers in this namespace, and the allowed namespace selector, it selects the namespaces in this project using the label that is programmed on the particular namespace with the project ID. So if you have project A and it has namespace 1, namespace 2, now these two namespaces will have a label called project ID is A. And this label is used to program the network policy. So that's one of the network policies. And there are like a couple of other policies which are based on host ports and host network to enforce the same kind of stuff. So at this point, we did not document this the internal details. The main reason being, we wanted to make it as abstract as possible to the end users. Like, users don't have to worry about it. It's taken care of by Rancher. So the documented thing is, projects are the kind of the boundary of separation or the boundary of the security stuff. Within the project, you can communicate. Outside project, no.
Okay, great. Thanks, Murali. That was awesome. It's a question that George asked, and I don't know if it's a great question for this meetup, but we'll try to dive into it. It says, do most people use development environments that are not local? We typically program locally, and I'm having trouble thinking about how to spin up a Kubernetes cluster on my local computer. Do most people develop on their local computer or on a remote platform? Maybe you can talk about Minikube and talk about sort of the kind of building in Docker locally and then pushing to Kubernetes and operations. This is an area that we actually have a lot of have been having a lot of discussions about internally, George, in the last couple of months. Darren and I, we've been talking about some of the challenges we see in teams that are kind of familiar with Docker, but then find the Kubernetes learning curve to be quite challenging. I don't know, Murali, do you want to maybe talk about that a little bit?
Yeah, sure. So there are like multiple ways to run a Kubernetes cluster locally. Like Shannon mentioned, you can use a Minikube. The way I run it personally is I use a VirtualBox to spin up three different nodes, and I use them to register to my Rancher server running locally on my laptop. So that's one way. The other developers in our company, they use Minikube.
I use Minikube. It has some problems sometimes, so it sometimes crashes, so you have to delete, recreate it. But as for the developer, it's not a problem for me because you usually like start clean. So yeah, so I have a OSX and I use Minikube for the development.
So there was a question from Rajan, and he said, is there a reason that Rancher chose Sky DNS in KubeDNS instead of using something like Core DNS?
Yeah, so Sky DNS has been stable for a while, and Core DNS is becoming stable only in the very latest. I think it's going to be stable in Kubernetes 1.11, and that's where we're going to consider the switch. We haven't considered the switch for now because Sky DNS proved to be working, and Core DNS was still in beta.
Awesome. So here's a question. Scott asked, he said, and this is a good question for you, Alena, he said, is it possible to create an AWS internal load balancer inside of Rancher? So essentially what you did earlier, but not given an external IPs.
If it is possible to create
like an internal load balancer within Rancher. So I think two Rancher services running inside Rancher, but then a load balancer maybe balancing traffic between service A and service B. I think that's the question, but I might be wrong.
Yeah, but you said it's internal, so it's not like exposed to the outside. So it really depends on the so it really depends on the Ingress controller. I believe that Nginx Ingress controller, like you can deploy it in the way so it's not exposing itself via the node port service and only available like via the cluster IP. So basically, if it's Nginx, just replace the node port service with the cluster IP service for the Nginx Ingress controller definition, and then it's going to be available from the inside on.
I guess you said it also, I saw the second half of the question. We said it would be a layer 4 TCP load balancer, but internal to the VPC.
Layer 4 TCP load balancer, but internal to the VPC. So I'm only trying to understand whether like what would be the cloud provider, what would be the Ingress controller provider in this case, and would it even be the Ingress controller versus like a load balancer service? Yeah, I have to look it up. Like, what are the best practices for this scenario?
Okay, great. Willard asked, he said, is there any design patterns for using Ingress with bare metal RKE clusters using external DNS? Can't seem to find any definitive docs on how to set this up.
There is nothing RKE specific. Like you should think of the cluster set up by RKE as any like vanilla Kubernetes cluster with the add-ons of your choice. So let's say you decide as for a key, you decide, okay, I want to use my Nginx Ingress controller, but then what would be your the DNS provider, and the way your Ingress controller is exposing itself either via the node port or via the so bare metal is going to be the node port. So there's going to be some controller that you can deploy in cluster. You can deploy it as a native Kubernetes application that will just monitor the node updates, creates, removes, and it will update and as it knows, for example, like that your Nginx Ingress controller is listening on port 8443 on a particular set of the nodes, it will automatically update the external DNS of your choice. And as it's going to be like native Kubernetes application, I would suggest that it should be written in Go. Yeah, so there are plenty of examples out there. I'm pretty sure there's something exists for the Route 53 controller that you can deploy as a native Kubernetes application that should do something similar.
Just to add to what Alena just said, in one of my recent customer engagements where they were using on-prem bare metal servers. So what these customers have done is, so they have a wildcard. So in the cluster, so they have a dedicated host which are used to deploy the Ingress, and those hosts are marked with labels, and you have Ingress running only on those specific nodes. Now, when applications are deployed on this cluster, what they do is they have a FI load balancer in front of this cluster, which has a wildcard entry like star dot, apps dot, company.com, and this wildcard entry, it points to the 3 different IPs or the nodes that are running the Ingress. So now from the outside, if somebody wants to access the services running on this bare metal cluster, what they do is they say service, some awesome web app .apps.company.com. It hits the FI load balancer. It gets load balanced to the 3 or 4 different nodes which are running the Ingress controller, and from there the traffic goes to the actual worker nodes where the pods are running. So this is the kind of a 3-tiered architecture they have come up with when using bare metal.
But the part that actually updates either DNS or the external load balancer with the node IP addresses can certainly be automated. Like,
yes,
if you have a limited set of nodes and you know that it's constant, then yes, you can update it manually. But for the long-term solution, it's better to automate this process.
Yes, I agree with you.
Awesome. There's still so many questions, but I think given that we're 2 hours in, we're probably going to have to sort of wrap up now, 2.5 hours in. So everyone who attended today, I can't thank you enough for coming and asking so many great questions. Murali and Alena, thank you for your presentations and for staying on. We'll try to stay on and answer a few more questions if we can on the Q&A Slack, but otherwise, please join us again next month. As I said, we're going to be talking about service mesh. There's some new stuff Darren's been working on that he's going to be demoing. So we'll be diving into this. And like I said, if you need more details, Slack us on the slack.rancher.io channels. We're all on there. I'm just SMW355. I think Murali is, what's your handle? It's leo.cloud?
Yeah,
and then Alena is Lemonjet. So we're all on there. Please ping us if you need anything, and we'll try to help you out with whatever you're running into. Thank you, everyone. Have a wonderful day. Thanks, guys.
Thank you.